Trial Circuits 4. As with all these videos, if you want to work these on your own, stop the video and do that, because I'm not going to wait for you. I'm just going to charge into it, and you're going to learn better if you try some things on your own and then check your work. Enough said. Consider the circuit shown here. Note in particular the value of R2 compared to R1. So R2, 2,000 ohms. See that? 2 kilo ohms. And R1 is only 4 ohms. This R2 is quite a hefty resistance compared to R1. At time 0, determine the current I in the left half of the circuit. We're going to flip this switch to point number 1 here. So should I draw that in? There we go. We're going to flip the switch right there. What's going to be the current in the left half of the circuit? Well, remember that an inductor acts like an insulator at that very first instant. When we flip the switch there, the current is going to want to try to change, but at that first instant, the inductor will prevent that. It will ultimately fail, but that's what it does at first. What's the voltage drop across the resistor at that first instant? Well, if there's no current, then there can't be any voltage drop across that resistor. And what's the EMF that will be in the inductor? The EMF will be exactly equal to the EMF of the battery. And it will be directed, let's see, because the current is going to want to try and go clockwise around this left loop. The inductor is going to want to fight that. The direction of this, which wasn't asked, we're just adding that in. The direction would be pointing up, wouldn't it, towards the top of the page. After we flip the switch to point 1, again, let me draw that in. Flip that switch right there. What about at time infinity? So now things have been happening for quite a while. Now what's the current going to be like? The current won't be changing anymore. So this inductor is simply an ordinary wire. So all we have is 12 volts from the battery and 4 ohms of resistance. So I think that's going to be 3 amps going clockwise around the left side of the circuit. What's the voltage drop across the resistor? All of that voltage from the battery will have dropped by the time we go across that resistor. So I think it's going to be 12 volts. And what's the EMF in the inductor? The inductor is taking a nap right now. He's perfectly happy. Whenever the current isn't changing, he's all good with it. Now we're going to flip the switch to point number 2 down here. We're going to make that connection right there. What's the current going to be in the right half of the circuit? Well, let's go back to what was at the top of the page here. We had 3 amps of current going through this inductor. 3 amps. It was going this way. Let me write that in there. 3 amps was going through that inductor. And remember, that inductor, he was perfectly happy whenever there was 3 amps and as long as it wasn't changing. But as soon as we flip over to point 2, now the battery isn't providing oomph anymore, and this inductor, suddenly there's no push to keep that current going, and so the current is going to try and drop. But the inductor, remember, doesn't like that. The inductor is going to keep that current going for that first instant. We're going to have 3 amps going around the right side of the circuit. So what would the voltage drop be across resistor number 2? Well, across resistor number 2, look at that. If it has 3 amps going through it, and it's a 2,000 ohm resistor, that is a 6,000 volt voltage drop. Exclamation point by that. Holy buckets. And what's the EMF in the inductor? 6,000. You get quite a bang there in terms of your voltage at that first instant when we flip that switch.